Hello children, I am Bindu and welcome back to another video. Previously we have learnt about the refraction of light. Now without getting late, let us gather some information about lens and image formation by lens. Learning outcomes. At the end of this session, you will be able to understand about lens, convex lens, concave lens, some important definitions regarding it, and the image formation by these lenses. Keywords: lens, convex lens, concave lens, center of curvature, radius of curvature, principal axis, optical center, aperture, focal point or focus, focal length, Before starting the session, let's look at this concept map. A lens is formed when a transparent material is bound by two surfaces, of which one or both surfaces are spherical. This means that a lens is bound by at least one spherical surface. In such lenses, the other surface would be plane. A lens may have two spherical surfaces bulging outwards. Such a lens is called a double convex lens. It is simply called a convex lens. It is thicker at the middle as compared to the edges. Convex lens converges light rays. Hence, convex lenses are also called converging lenses. Similarly, a double concave lens is bounded by two spherical surfaces, curved inwards. It is thicker in the edges than in the middle. Such lenses diverge light rays. Hence, concave lenses are also called diverging lenses. A double concave lens is simply called a concave lens. Lenses can be of various types. Some typically lenses are the double convex lens, Plano-convex lens, concavo-convex lens, double concave lens, plano-concave lens, and convexo-concave lens. Now, let us know about some of the important terms regarding lens. Each curved surface of a lens form a part of a sphere. The center of these spheres, which contains the part of the curved surface, is called the center of the curvature of the lens. It is represented by the letter C. Since there are two centers of curvature, we may represent them as C1 and C2. The distance between the center of curvature and the curved surface is called the radius of curvature, R. Radii of curvature is represented by R1 and R2 respectively. An imaginary straight line passing through the two centers of curvature of a lens is called its principal axis. The central point of a lens is its optical center. It is usually represented by the letter O. The effective diameter of the circular outline of a spherical lens is called its aperture. A parallel beam of light incident on a lens converges or seems to emanate from a point on the principal axis. This point of convergence, or the point from which rays seems to emanate, is called the focal point or principal focus or focus, F. Every lens has two focal points. The distance between the focal point and the optical center is called the focal length of the lens, denoted by F. Now, we are going to see the image formation in lenses using ray diagrams. Before that, we will learn about the rules of ray diagrams. A ray of light from the object parallel to the principal axis. After refraction from a convex lens, passes through the principal focus on the other side of the lens. In the case of a concave lens, the ray appears to diverge from the principal focus, located on the same side of the lens. A ray of light passing through a principal focus after refraction from a convex lens will emerge parallel to the principal axis. A ray of light appearing to meet at the principal focus of a concave lens after refraction will emerge parallel to the principal axis. A ray of light passing through the optical center of a lens will emerge without any deviation. Lenses form images by refracting light. The nature, position and relative size of the image formed by convex lens for various positions of the object are shown here. When an object is placed at infinity, you will get an image which is real and inverted at focus f2, which is highly diminished and point-sized. When an object is placed beyond 2f1, you will get an image which is real and inverted between f2 and 2f2, which is diminished. When an object is placed at 2f1, you will get an image which is real and inverted at 2f2, which is of the same size. When an object is placed between f1 and 2f1, you will get an image which is real and inverted beyond 2f2, which is enlarged. When an object is placed at f1, you will get an image which is real and inverted at infinity, which is infinitely large or highly enlarged. When an object is placed between focus f1 and optical center O, you will get an image which is virtual and erect on the same side of the lens as the object which is enlarged. When an object is placed at infinity, you will get an image which is virtual and erect at focus f1. Which is highly diminished and point-sized. When an object is placed between infinity and optical center O, you will get an image which is virtual and erect between focus f1 and optical center O. Which is diminished. A concave lens will always give a virtual, erect and diminished image, irrespective of the position of the object. Thank you.